Hello coders. Welcome back to the recipe of code. Hope you all are doing well. Let's see what all we are going to cover in today's session. Recursion. Hello, I think I look pretty decent. So today, first of all, we will start with understanding what recursion is. Then we will see some examples, how the recursion works. Then we will go through the thinking process, how to approach recursion. Then Deep Coder will solve a famous problem, the Tower of Hanoi with you. Then we will see what to do next. What comes to your mind when you hear the word recursion? Recursion comes from the word recur, which means occurring again periodically. See this GIF. This is how recursion in action looks like. Doesn't this looks cool? Recursion is an interesting and very much important topic. It has a wide variety of applications in many important algorithms. Now let's understand how does recursion works in code. Suppose you have a mixer and you have to make juice. How will the mixer produce the juice? Have you ever thought this? When a mixer sees a fruit as input, it starts cutting it into lower pieces and keeps breaking it until there are no little pieces to break down them further into smaller pieces. This is how a mixer would have worked if it were a software. Here we have two cases. First is the base case. Second is the recursive case. The base case is the case of termination. Without the base case, the recursion will repeat infinite times. The recursive case is the case that repeats itself, breaking down into subproblems until it reaches the base case. For example, you want to go home. We can define the operation find your way home as: if you are at home, stop moving. Take one step toward home. Find your way home. If you won't be able to identify your home, then you will be lost and stuck in infinite recursion. So here, identifying your home is considered as the base case.
Hello friends, Deep Coder is back. So today we have learned a lot about recursion. What is the definition of recursion, how recursion takes place, and we have also taken a good example of mixer, like how a mixer cut a fruit into simpler pieces and make juice out of it. So we have covered all this, and we have also taken the example of a house where a man wants to reach his house. So how can he break this complex problem into simpler problems? So I am going to help you how to think recursively. So we have already studied, let's revise. Recursion. Now a recursive function has two parts. First part is a base case. And second part is recursive case. So base case and recursive case. So what is base case? Base case is the case where function directly returns the answer so that we can obtain what we wanted to get. Now recursive case. Recursive case is the case at which the function breaks itself into simple problems and calls itself back. Let's discuss with a very famous example of Fibonacci series. So what is a Fibonacci series? So Fibonacci is a sequence of number in which ith number is the sum of I minus 1th and I minus 2th number. Means this number is sum of this and this. 0 and 1 makes 1. 1 and 1 makes 2. 3, 5, 8. Okay. So this is our problem. Our problem is f of n. Okay. Where n is the nth. F of n is nth Fibonacci number. So now how can we break into simpler problems? as we all saw that we are summing up I minus 1th number and I minus 2th number. So what will be our recursive case? F of n is equal to f of n minus 1 plus f of n minus 2. So this is our recurrence relation. So now let's build the recursion tree and see how does it works. So suppose we have n is equal to 5. Okay, so we need f of 5. Okay, so f of 5 gets converted into simpler problems. F of n minus 1, that is 4, and f of n minus 2, that is f of 3. Okay, so we have to sum it up. Okay, so this function is breaking into simpler problems. So now this becomes complex problem, and this is another complex problem. So we again break it into simpler problems. So it gets converted to f of 3, f of 2, f of 2, f of 1. So f of 2, f of 1. Okay, so this is our recursion tree. So we have to think of our base case. When will the function terminate? So as we have seen our sequence 0 1, so this is first index, first position, this is second position. Okay, so either this we are summing, initially we are summing 0 and 1. Okay, so this will be our base case. Base case is the bottommost number. Okay, so it is the most simpler part. Okay, so more simpler part is at second position and first position. Okay, so when f of 1 or f of 2 comes, okay, so we'll terminate, so we'll return 1. Okay, and here 0, here we'll return 1, here we'll return 1, here we'll return 0. Okay, so we have to sum it up, plus. Okay, so we have to sum it up. 1 plus 0, what does it make? 1. 1 plus 1, 2. 2. Now let's see here. 1 plus 0, 1. So 1 goes here. Okay, 2 plus 1, 3. So 3 here. So now see, 0 1 1 2 3. So third, fourth, fifth. So this is f of 5, that is 3. So we get our answer. So you saw how recursion takes place. Okay, so now let's take another example. You are given a string, you have to reverse it. So pause the video and try this question yourself. I hope you have tried this question. So let's see how can you solve this problem. So what is our larger problem? Larger problem is that we are given a full length string, we have to reverse it. Okay, so first part is to place the first letter to the last position. Okay, this is our simpler recurrence. So what can you do? Reverse. See, first what we are doing, we are placing this in our last position, then we are reversing this part again. So we will reverse as, we can slice it from 2 to n, then we add first position to the last position. Okay, s of 1. So this is our recurrence. Relation. Okay, So what will be our base case? So base case is when we have single character, when we have g, then we can directly return g. Okay, so if s dot length is equal to 1, then we return s. So that's it, as simple as that. So recursion is very simple if you can think it and follow the process. So friends, now we are discussing Towers of the Hanoi problem. So we have n disk stacked on top of each other. Okay. Now these disks are stacked from descending order. Like the bottommost disk is the largest. Then we have smaller, then smaller, then we have smallest disk on the topmost position. Okay. So we have three rods. Now our task is to move the disk from first position to the last position. Okay, now this is the first road, and there is a condition given that we cannot place larger disk on the smaller disk. Okay, so let me give you an illustration. If we start moving it, we can move it here, but we cannot place this bigger disk on this smaller disk, so we have to put it here. Then we can put this smaller disk on the larger disk. So like this, we have to shift all the disks to this last position. Okay, so here let me try. So we have to do like this. So we have to use this middle disk as an auxiliary disk. Okay, so now let's let's take a simpler case. So for disk is equal to 1, like if we have one disk, so what we can do, we can just simply pick this disk and move it here at the last position. Okay, so see, it takes no time. So this is the most simplest case. As I have explained earlier that when you have the simplest case, then it becomes your base case. So now let's write our base case. Now this will be our base case. If n is 1, then we can simply move disk 1 to disk number 3. Just it is a simple base case. Okay, so we discussed the base case. So now let's go to the recursive case. Let me clear it out. Now let's now take 5 disks. So we get 5 disks and we do it restart. So what will we do in our recursive case? In recursive case, just think about the simpler problems. So what do you think will happen when we take n minus 1 disk and place it on the auxiliary rod? Okay, we take n minus 1 disk and place it on the auxiliary rod. Now we can simply put the last disk and put it in the last rod, as we have seen in the base case. Okay, so we are assuming that we have already placed n minus 1 disk on the auxiliary rod. Okay, now we can place the last disk to the last rod. This will be our recursive case. So now let's try to code for this. Okay, let me clear. Okay, so here will be our recursive case. So suppose you have a function called Tower of Hanoi and you have 4 arguments. N is the number of disk, and you have from the first road from which you have to transfer the disk, then third is aux, which is the auxiliary rod. Then you have the last rod. Now pass the arguments and call the function. Towers of Hanoi, we pass the arguments 5, 1, 2 and 3. Okay, so now our recursive case. Okay, so recursive case, in recursive case, first of all we will call our function and move n minus 1 disk from rod number 1 to rod number 2 using 3 as the auxiliary. Okay, so we have seen in this example that we place n minus 1 disk to the auxiliary rod first, then we place the last disk to the last rod. So now this, now we can just simply write that move disk n to from 1 to 3. So we can just simply place the last disk to the last rod. Okay, now Tower of Hanoi, we are calling the function again and we place n minus 1 disk back from second rod to third rod using 1 as auxiliary. So this is our recursive case. So as you can see, it is very simple. Just you have to think about the simpler solution. Don't think about uh, the conditions which are between. Okay, these are the tasks of computer. Just think about the just simpler case than the complex one. Okay, like we were given n, so we thought about n minus 1 disks. Okay, so rest all work computer can do. So let me give you an illustration. Like 3, we take 3 disk. Okay, so first let me place it here, then here, then here. Then see, this is the condition I was talking about. Here you have n minus 1 disk here. Okay, you don't know how did it come here, but just you know that at last step you have n minus 1 disk here and you can simply place the last disk to here. Okay, now and we can place here. Then now we have completed our puzzle. So thank you. Now don't forget to like, subscribe and share to your friends.